Добрый день, уважаемые коллеги и гости. Позвольте заседание.
We are beginning the panel session for the defense of the Thesis by Polina Lobanova. The specialization is 2250028, Oceanology. The topic is satellite-derived algorithms of primary production assessment in waters with various oceanographic conditions, case studies of the Northeast Atlantic and the Japan East Sea. By Rector's Order number 2610/1, as of the 5th of April 2018, I, Professor Evgeny Zakharchuk, Doctor of Science in Geography, Professor and Acting Head of the Department of Oceanology, St. Petersburg State University, was appointed Chair of the Dissertation Board. Let me introduce the members of the Dissertation Board. Tatiana Belanenko, Doctor of Science in Geography, Professor of the Department of Oceanology, St. Petersburg State University. Vasily Dmitriev, Doctor of Science in Geography, Professor of the Department of Land Hydrology, St. Petersburg State University. Oleg Kopilevich has joined us remotely via Skype, Doctor of Physics and Mathematics, Shirshov Institute of Oceanology of the Russian Academy of Sciences, and Professor Georgi Ishizaka, PhD in Geography, Professor of Nagoya University, Japan. Under the federal law as of the 23rd of May 2016, number 127, on amending Article 4 of the Federal Law on Science and State Scientific and Technical Policy, St. Petersburg University is entitled to confer its own academic degree. The corresponding order on the procedure of granting academic degrees at St. Petersburg State University was issued on the 1st of September 2016. The number is 6821/1. According to the order, the panel discussion is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. The dissertation board today consists of 5 people, 5 of which are present, including 2 board members who are attending the defense remotely, Professor Kopilevich and Professor Ishizaka of Nagoya University. Therefore, we have a quorum. Let me focus on the agenda of the panel session of the dissertation board. It will not exceed 2 hours. Number 1, the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Chairman's reply to questions, if any, 5 minutes. The candidate's presentation providing an overview of and findings of the research, no more than 15 minutes. Questions to the candidate regarding the presentation, no more than 2 minutes for each question. The candidate's reply to the questions, 2 minutes per question. 4. Chair's overview of the submitted reports on the Thesis. All the reports were posted on the official SPB website, so only critical remarks and questions are read out. 5. Reports on the Thesis. No more than 5 minutes per each report, no more than 5 minutes for critical remarks of the members of the dissertation board. Questions from the audience. The floor will be given to the non-board attendees. They can give a brief account of their ideas and/or ask questions to the candidate about the research. No more than 5 minutes per person. The candidates' comments about the talks given by non-members of the board. Presentation of the candidate's thesis supervisor, no more than 5 minutes. The discussion of the results of the defense, no more than 3 minutes per each member of the dissertation board. Open balloting, vote counting, and recording the results in the minutes of the session, 5 minutes. 10. Deciding upon conferring or not conferring the academic degree. And finally, number 11, candidate's closing speech, no more than 2 minutes. Members of the dissertation board, are there any questions about the agenda? There are no questions. Before we proceed with the agenda, I kindly ask you to switch off your mobile phones. The panel session of the dissertation board is being recorded and broadcast on the internet on the SPBU website. It has been interpreted into English. The first item on the agenda, the chairman's report on the documents provided by the candidate and their conformity to the requirements. The thesis by Polina Lobanova was submitted in conformity with the requirements for the academic degree of the candidate of science in geography, specialization 250028 oceanology, the topic satellite-derived algorithms of primary production assessment in waters with various oceanographic conditions, case studies of the Northeast Atlantic and the Japan East Sea. It was approved for defense by the order of the SPBU Academic Secretary on the 5th of April 2018, order number 2611/1. The candidate has submitted the following documents to the SPBU Academic Secretary. An application to Professor Nikolai Kropachev, Rector of SPBU, on the approval of the thesis for defense submitted on the 11th of December 2017. 2. A copy of the university diploma. 3. Letter of verification certifying that the candidate passed the qualifying exams on the postgraduate course. 4. Report of the academic supervisor, Igor Bashmachnikov, candidate of science in geography, associate professor SPBU. A list of published works containing same items. They are included in the Russian Science Citation Index. 4 works are published in peer-reviewed journals recommended by the Ministry of Education and Science, Scopus and Web of Science Index journals. 3 papers are conference proceedings, one of which is in Scopus indexed edition. She has also submitted a thesis in Russian and English, a printed version with the manuscript copyright and a digital copy. The above-mentioned documents comply with Item 12 of Section 3 of the Order on Granting Academic Degrees in St. Petersburg State University. This is Appendix 1 to the order. The next item on the agenda is the candidate's presentation.
Thank you. Good afternoon, dear members of the board. Good afternoon, Professor Ishizaka. I'm beginning my presentation. Primary production is a rate of conversion of the inorganic carbon compounds to organic ones normalized to a certain volume. Phytoplankton uses nutrients to form components of their cells and in turn increase their phytomass. Therefore, primary production determines primary energy flow through the trophic chain in the world ocean, ensuring the function of its ecosystems and its biological and fishery productivity. The estimation of primary production is limited by the methods of its manual measuring. And in order to study it at various spatial and temporal scales, it is necessary to use mathematical modeling. Primary production is the rate of photosynthesis depending on the adaptation of phytoplankton communities to change in local oceanological conditions. Therefore, the use of remote sensing information expands our possibilities and makes it possible to obtain the estimates within a time interval of a day or even more. The major input parameters are as follows. Photosynthetic active radiation, assimilation number, which is retrieved as a function of the surface temperature, and a biooptical index, which is retrieved using the data about the ocean color. Usually we use chlorophyll A as this index. On the one hand, satellite models allow us to study the issue, but on the other hand, there are some limitations here. Therefore, to estimate the accuracy of primary production retrieval using satellite-derived models by regional validation of modeled assessments is necessary for using the models. So, the goal of the study is to estimate the accuracy of satellite-derived primary production models in waters with various oceanological conditions. So, we have set up the following objectives to reach this task. Methods of primary production retrieval in the Northeast Atlantic using different models and algorithm for estimating the accuracy of satellite-derived primary production models. We have validated the models and also conducted the accuracy of the models and chose the best regional model. We analyzed the sensitivity of the models and also analyzed the reasons for the errors that may arise. The main ideas to be defended. Methods of primary production retrieval in the Northeast Atlantic Ocean using PSI, PSM and absorption-based models with originally selected values. An algorithm for estimating the accuracy of satellite-derived primary production models. Main causes of the errors of satellite-derived primary production models in the Northeast Atlantic and the western part of the Sea of Japan. For primary production, we used modern and full database about the ocean of the color provided by the CCI Ocean Color database. The validation was conducted in the North Atlantic area. Here the data represents merged information from 3 spectroradiometers. For primary production retrieval, we use 3 most common models. Gbm model is one of the most common models since all its parameters can be determined remotely, and this gives it a number of advantages over other models which require the inclusions of in-situ experimental data. APHPP, the absorption-based model. The algorithm for calculation of absorption coefficient makes it possible to minimize the effect of the dissolved non-phytoplankton organic particles. Although the PSM model is an empirical one, its PI function, which describes the dependence of the photosynthesis on irradiance, is based on the theoretical ideas, and therefore we can call it a semi-empirical model. When we retrieve primary production, it's important to take into account the adaptation of phytoplankton to local oceanological conditions. Therefore, we use regionally selected models of photosynthetic parameters which were borrowed from literary sources, and the further checkout showed that the data are consistent with the newly published data, which was released in 2017. For satellite-derived primary production models, we usually use surface values. We find it appropriate to integrate PI functions over the depth. Besides, PSM and absorption-based models involve retrieving primary production at a specific depth, while VGPM retrieves primary production for the water column. On this slide, you can see the equation which allows us to calculate the depth of the euphotic zone. Usually, we use the parameter which was calculated remotely. But since the light dispersion in the water depends on the electromagnetic spectrum, we use the coefficient for the whole surface of the photosynthetic active radiation. We also use the Morel algorithm for our calculations. Here you can see the new equations. The functions were integrated with photoinhibition and without photoinhibition. Here you can see the equation which takes into account photoinhibition in the VGPM model. On the slide you can see PI models with photoinhibition and without photoinhibition, and also new equations for primary production for PCM and absorption-based models with photoinhibition. The validation of the models was carried out in different seasons and in different biogeographical provinces of the North Atlantic Ocean. To minimize the discrepancies between the modeled and in situ data, we compared the data averaged over space and time in mid-ocean and in the offshore area. But in order to take into account the regional specific characteristics, we compared specific points. Plymouth Marine Laboratory provided the necessary data. The comparison of the data showed us that the PCM model works better in this region. However, in the offshore area of the Iberian Peninsula, the absorption-based model works better. We can explain this by the fact that the absorption coefficient is used here, and it allows us to minimize the impact of non-living organic matter. As you see, this advantage doesn't work in mid-ocean, since here we do not have non-living organic matter. And here the overestimated values in the absorption-based model can be explained by the error in the satellite assessments. The validation of models was also carried out in several stages. First of all, we constructed scatter diagrams, which allows us to understand if the diagram works, if the model works good at different values. We also analyzed the Taylor diagram, which take into account the standard deviation and center pattern root mean square. However, the use of separate statistics can give us an inappropriate assessment of primary production retrieval. Therefore, we used a set of mathematical statistics, which allows us to see how the models work. We compiled such aggregated models for different seasons and for different regions. We analyzed 95 stations as well. And here you can see an aggregated table. In this table, the plus sign shows the cases when modeled assessments are consistent with in situ assessments. As you see, the PSM model can be recommended as a regional one for this part of the Atlantic Ocean. The analysis of reasons for errors in satellite models was carried out with the help of the sensitivity analysis, using the North Atlantic as an example. To this end, we constructed a box diagram where the size of the rectangular characterizes the contribution of each input parameter into the overall error. Here you can see that the largest contribution is made by the bioptical index. I mean chlorophyll in PSM and VGPM models, as well as the absorption coefficient in the absorption-based model. Please, I would like to say that here we see different scales. So the other parameters are given at a larger scale. The next parameter that makes a contribution are the assimilation number in VGPM and PSM models and the maximum quantum yield in the absorption-based model. The third parameter is the one that characterizes the dispersion of illumination in the water. Sources of errors were analyzed in the western part of the Sea of Japan because we have data about the variability of oceanological parameters. The data was provided by the Pacific Ocean Institute of the Academy of Science. We lack in situ assessments for primary production in the Japanese Sea, therefore we use two models for the retrieval: the VGPM model and the model developed by the Pacific Ocean Institute of the Academy of Science, which is based on the theoretical assumptions of the nature of photosynthesis. To compare the data with the so-called field assessments, we used satellite assessments using VGPM models and the ocean productivity database. The analysis of errors allows us to identify three major sources of errors. Number one, the accuracy of the bioptical index. In this case, it's chlorophyll A. Here you can see a table with a systematic error. Please have a look at columns 3 and 4. Here you can see that in cases when primary production, when the retrieved primary production is overestimated, the satellite-derived chlorophyll is also overestimated, and vice versa. The results are consistent with analysis of the sensitivity analysis, which shows that the major contribution is made by the bioptical index. The next source of errors is the oceanological conditions or water stratification. We have analyzed the data provided by two expeditions. In autumn 2005, satellite assessments are overestimated, while in autumn 2018, they are underestimated. So how can we explain the difference? We see that in 2005, the waters were highly mixed and the vertical gradient was virtually absent. However, in 2018, the waters were highly stratified and the situation was different. According to the VGPM model and many others, they take into account the chlorophyll in the subsurface area So here some part of chlorophyll is not taken into account, therefore we see the underestimated assessment. And the next source of errors can be attributed to the accuracy of different parameters such as assimilation number. In autumn 2005, the satellite assessments were close to in situ assessments, but the systematic error is not large and quite minimal. So in this case, we do not see a large contribution to the overall error. So the assimilation number is the regional number for the Japanese Sea, but in the Gbm model, the assimilation number was retrieved as a function of the temperature of the surface layer. So in autumn 2005, this value was overestimated, and it is higher than the in situ assessments. As a result, we have a weak vertical gradient of chlorophyll and overestimated satellite assessments. So, we have developed more accurate methods for primary production retrieval in the Northern Sea Atlantic. We use regionally selected values of photosynthetic input parameters and use new equations for photosynthesis irradiance curves of PSM and absorption-based models. We use a complex algorithm for estimating the accuracy of satellite-derived primary production models. We also have shown the main sources for the errors which arise in satellite-derived assessments. The major errors are related to the accuracy of the bioptical index, stratification of waters, and the accuracy of photoadaptive parameters. Thank you. Thank you for your presentation. Are there any questions? Polina, let's imagine a situation. So it's a sunny day. However, the monitoring data shows us that net primary production is close to zero or even negative. What factors could have contributed to this situation? Well, please tell us about the factors that could provide the situation. I would like to say that in this case, the synthesis of organic matter is not that high, and this is connected with the process of photoinhibition, because here the rate of photosynthesis is lower. If the waters are stratified, the phytoplankton are in the surface layer, therefore we have photoinhibition. Besides, there can be a limitation by nutrients, which means that the lack of them does not contribute to the increase of the phyto mass. So these are the major factors that I would like to point out. And there's another one. For example, destruction, or if we have a large phyto mass, there are some issues that make the breathing costs higher. I have a small comment. Please use a better term, which is exchange for the Do you have any other questions? Professor Ishizaka, would you like to ask a question?
Yes. Okay. My question is, okay, you have you compared several different models with also different parameters. Okay, and your comparison shows certain for certain parameter, maybe certain model is I think good, but how you because each model have a different parameter numbers and different parameters, so how you decide which model is a really best model?
It's very difficult to give one answer to this question because each model has its own advantages and disadvantages depending on the region and different things such as the season. But due to the validation and due to the complex algorithm that I have developed, it is possible to give an answer to this question and give the model with the best mathematical statistics. For example, it had the lowest number of errors. And this is, I would say, the PSM model, if we speak about the Atlantic Ocean. But this depends on the region, and we must carry out a specific research for each region. Are there any other questions to the candidate? Professor Kapilevich, would you like to ask a question? I do not have any questions. I didn't hear Professor Ishizaka's question, but I heard the reply to the question, and I'm happy with the reply. Professor Belonenko, would you like to ask a question? So you have compared modeled assessments of primary production. You compared in situ data and satellite derived assessments for spring 2004 and for autumn 2005 and 2011. You have obtained assessments and you have chosen the best model. Is it possible to use the models for the summer period? For this, I think it's better to use some validation, because these values of photosynthetic parameters have been taken for summer and autumn periods. But in the Japanese Sea, it is possible to compare spring and autumn seasons, but in summer we see highly stratified waters in the region. Therefore, there is not much primary production, so I don't think that we should use the algorithm for the summer period. Are there any other questions? I have another question. Please tell me about such thing. So, what is this specific feature of primary production algorithm in your thesis? I mean the methods. First of all, we used regionally selected input parameters. Secondly, we integrated PI functions and offered new equations for PSM and absorption-based models using photoinhibition and without photoinhibition. Many scientists use the light attenuation coefficient for 400 and 49 wavelengths. But as I have already said, since the illumination in underwater is determined by the electromagnetic spectrum, this retrieval is not quite correct. Therefore, in my thesis, we use the Gbm coefficient for the photosynthetic illumination parameters. Are there any other questions? I have another question. All the models that you have described are connected with the calculation of constants and coefficients. So to assess the constants and coefficients, it is necessary to take into account the regional values and characteristics. Don't you think that if you used more complete mathematical models that take into account the dynamic process, such as advection or turbulent eddies, then you would have avoided the drawbacks of your models? For example, it's difficult to use your models in operative conditions. And we should use different models for different regions of the ocean. Do you understand the question? Before answering the question, I would like to differentiate the two processes. When we speak about primary production model, we speak about photosynthesis. And it's important to take light into account. Therefore, all the models take into account the PI function. But the increase of phytoplankton, which happens next, is a more complex procedure. And here the influence of the dynamics can be taken into account through the concentration of chlorophyll A. So we see that the concentration of chlorophyll A increases with the increase of the phytomass. So to some extent, the models take into account some dynamic aspects. I would say that the models take these issues into account indirectly through the concentration of chlorophyll A. The regional values are determined by local oceanological conditions, but they, to some extent, take into account the dynamics through the concentration of chlorophyll A and the value of photosynthetic parameters. Are there any questions? No more questions. Now, please take a seat. We are going to read out the reports. We have received 5 reports on the thesis. The thesis of the chairman of the Dissertation board and other board members. There are no external reports on the thesis. Of the 5 reports on the thesis, all 5 are positive. Since all the reports on the thesis have been posted on the website of St. Petersburg State University, and everybody has had a chance to read out the reports, I ask you to focus on the critical remarks in your reports. So the floor is given to Professor Belanenko.
Professor Belanenko, welcome. Let me read out the critical remarks that I have. To my mind, the major disadvantage of the thesis is that the candidate ignores dynamic factors when analyzing the models. At the same time, the ocean dynamics affects biotical characteristics to a great extent. There I provide some references to literature. This is what the section 1.4.3 of the Thesis states. Secondly, finding 1 and 2 provided for the defense are misworded. These are actually results of her study, but not the research findings. The third critical remark. When describing the data, the candidate does not provide references to the databases which are available in open access. Number 4, the candidate uses word-to-word translations from English. To my mind, this is a misnomer and it's incorrect. For example, Atlantic Arctic province. Number 5, section 3.5, sensitivity analysis of the models, does not explain why it is based on the data averaged by time and space for the year 2005. At the same time, she doesn't explain what's meant by extreme values, provided on figure 3.1.8. Number 6. In section 2, when describing the data, the candidate writes that she used the second and the third level data. If we refer to the thesis, however, we see that she only used the third level data. The final remark. The models were validated based on the 8-day estimates, which is wrong, because data averaged by time of primary production is compared with an in situ data obtained on a particular day. During this 8-day span, synthesis of organic matter can change, its speed can change, which might lead to mistakes and misinterpretations. Thank you for your remarks. Let me start with the first. And I have partly answered this question when answering to Professor Zakharchuk's question. When talking about primary production, we have to differentiate with photosynthesis and the growth of phytoplankton cells, which requires nutrients. In the first case, we have biogenic elements, which is mainly defined by dynamic factors, is not that important. It's not as important as enough light, because biogens are used to synthesize energy molecules. In the second case, biogenic elements, along with glucose, are used as construction materials for cells, resulting in an increase of phytomass. Light is the major energy factor, so most models use the dependence of photosynthesis and light. Dynamic factors are considered indirectly through the pigment chlorophyll A. If the concentration is high, it is indicative of the phytomass growth. The critical remark number 2. I should have paraphrased my research findings. I should have written, I have developed the methods of primary production retrieval, and I have developed a comprehensive algorithm of assessment of primary production retrieval. All the references to open access databases which are used to retrieve data are given in the bibliography. I assessed the satellite-derived models in several geographical and biological provinces in the area of northeastern Atlantics. This regional subdivision was developed by Alan Longhurst in the 90s of the previous century. I didn't find any Russian translation, so I had to offer my own translation, as I didn't find any relevant Russian terms for this original subdivision that he used. To analyze sensitivity, I used parameters averaged by space and time from satellite-derived data and the span of the change. Average data is more or less stable year in and year out. The sensitivity analysis was conducted using MATLAB software. I have used 3 third-level data in my study. This is data relevant to certain positioning data with certain spatial and resolution. In section 4, I used the 4-level data as it is classified by NASA. When analyzing the accuracy of models, it is better to conduct validation every day, every 3-4 hours. I have recently submitted a new paper, and there I took into account your critical remark, and there I provided validation of 1 year data, 1 day data, and 8-day data, and the study showed that there is no significant difference between the 2 sets of data. When we use the 1 day data, then the number of points is much smaller. For 8-day research, we analyzed the data from 95 stations, and only 27 points were used for 1-day studies. Thank you for your answers. I find them satisfying. Now we are turning to the next report. The floor is given to the board member, Professor Vasily Dmitriev, Professor of Land Hydrology, SPBU. I have 3 major. They are rather elaborate. The candidate has formulated 7 research findings. I find them too detailed. In general, there are 3 basic components of what makes the study novels. The candidate has developed a new compilation database which contains complete array of data on ocean color and other characteristics necessary for validation. Secondly, it's for the first time that the candidate has conducted comparative assessment of the efficacy of PP modeling using different models. Thirdly, the candidate has offered and validated comprehensive algorithms of statistical assessment of accuracy of PP retrieval. It was the first critical remark. The candidate has submitted 3 research findings. They answer different questions. What do I defend? So in the first case, these are methods of PPE retrieval in the northeastern Atlantic using PSM and APH PP models. The results are given in section 3.2. The second research finding, an algorithm for estimating the accuracy of satellite-derived PPU models. This is section 3.4. And the third is the range of accuracies in modeling. This means that we cannot discuss sections 3.1, section 4 of the dissertation, then the retrieval methods using other models, then comparative analysis of model and in situ data based on other provinces, seasons, stations. So in your further research, please take into account that research findings have to correlate with objectives. Another critical remark. I find the listing that you use in conclusion too complex. It's a multi-level list that goes like 1, 1.3, 1.3.1, and so on. Maybe the candidate should have provided more elaborate conclusions after each section, so that in the overall conclusion to the dissertation, we see more generalized conclusions. She could have provided aggregate data in a table that focuses on advantages and disadvantages of each model, that would include spatial and time factors, expected over and underestimation of values. Well, she later provided this table. Thank you for that. The conclusion lacks some important data which was still given in the dissertation. This is it. Thank you, Professor Dmitriev. Thank you for your report, Professor Dmitriev. As you have noticed, I considered 2 of the critical remarks you provided in my presentation. I have provided a comprehensive table that focuses on temporal and spatial characteristics and specificity as to different provinces, seasons, and so on. What concerns research findings, let me say the following. Sections 1 and 2 are descriptive, and section 3.1 is also descriptive. So I decided not to include information provided there into research findings. If I decrease the number of objectives of the research, then it would make the research not that effective. For better visualization, I considered your critical remarks in my presentation today. Talking about advantages of particular models, focusing on particular season and provinces, that wasn't the focus of my research, but it would be interesting to consider that in my future studies. I have analyzed only those stations which are located in the first type stations. I decided that diffuse attenuation coefficient there in NIA was taken from one research paper of 1998. So the depth of the euphotic depth in La Manche there was 9.8 meters. Thank you. Professor Dmitriev, do you find this answer satisfying? Let's get more specific. In your last reply, did you mean to say that you didn't focus on regions with different characteristics? Yes, only focused on those water basins which have phytoplankton. Do you now find answer satisfying? Yes, thank you. Now the floor is given to the member of this dissertation board, Professor Georgia Ishizaka.
Okay. Well, I think I found the dissertation is very well written. However, I have two major comments, and one is that about photoinhibition, and photoinhibition is obviously a very important term. But I was not quite sure in both study in the North Atlantic and Japan Sea how you decide whether you include the photoinhibition into the model or not. And the second one is about both description or discussion. I didn't see any thing about phytoplankton functional type or phytoplankton group. And right now, I think for the ocean color remote sensing community, the phytoplankton functional type is a very, very important issue. And obviously, the primary production, it really should be depending on the phytoplankton group. So I think that it has to be included in the dissertation. And finally, I think I also feel that you could have more direct description about some clear future study in the last part of your dissertation. Okay, those are my comments.
Thank you, Professor Ishizaka. Please answer the questions.
Professor Ishizaka, thank you for your comments. Your remarks are really valuable, and this is something that I didn't consider in my study. After your remarks, I have an idea how to and where to move forward. Talking about photoinhibition, for the analysis, I used models with and without photoinhibition. I did it just mathematically. Then I validated the models, and I tried to figure out which model worked better. I didn't consider the photoinhibition factor in the model itself. But this is an important and an interesting issue. The question is whether there is photoinhibition in these water basins, and should we consider that if it's non-existent, but I don't have relevant data that I could use in this study. So as I said, I only used models with and without photoinhibition with the use of mathematical functions. I only chose which model was better. For example, in the province NST, the Gbm model, which considered photoinhibition, showed a better result. Theoretically, I can try to explain photoinhibition in intense solar power, and phytoplankton is located in the top layer. There is almost no wind, so phytoplankton is kind of enclosed in the top layer. There is a lot of light, and this leads to photoinhibition. This is just a supposition, as there is not enough data. There is no data at all. We can consider that as a next step in future research. Talking about phytoplankton group difference and how they affect photosynthetic parameters, this is also a remark of great value. Rather, that refers to the biological aspect of research. So I paid minimum attention to it in my work. However, I understand how important it is to consider the types of phytoplankton in different provinces, and the temporal factor is important as well, the changes from season to season. I found out that in autumn and in ENA, models performed in a less effective way than in summer. A possible explanation is the change in the species of phytoplankton. Local speed of photosynthesis changed. So the local community had to change because the environment changed. I used photosynthetic parameters that I took from different literary sources by seasons and by provinces. I used them as constants. However, they correlate effectively with the new database published last year by Baumann and his colleagues. I can recommend these models as original. Still, we have to take into account all possible influences. To answer the question why models are effective in this or that season, we have to consider the range of species populating the phytoplankton communities. Talking about future directions of research is the possible increase in the number of models. There are 20 of them in total, but I only focused on the 3 of them. Colleagues from NASA early in the century conducted this research. If we increase the number of models, we can get more representative data and a better choice. This is one of the assumptions that I should consider for my future research. Considering your remarks, more accuracy assessment of photosynthetic parameters, especially by season to season and from province to province, should be considered, and linking of models' accuracy with vertical structure of the model parameters. This is it. Professor Ishizaka, do you find this answer satisfying?
Yes.
Thank you. We're now listening to the next report on the Thesis. Professor Kapilevich.
So the floor is given to Professor Kapilevich. Thank you. First of all, I would like to say that the issue raised in the thesis is very relevant and important. It's a very difficult and relevant issue, and scientists have been dealing with the issues for many years, and there's much to be done in the area. And the thesis decided to solve the issue, and I would like to praise her for that. And secondly, I would like to point out her comprehensive approach. I would like to say that this is one of the best dissertations in terms of the coverage. She takes 2 different regions, the Sea of Japan and the Atlantic Ocean. In the first case, she studies 3 models, and in the second case, she studies 2 models for different seasons. And she used data of primary production retrieval, and also she used different input parameters. So she has done a very impressive job. Her reference list is also quite impressive, 334 items on the reference list. And the research findings are validated and credible. I have one critical remark about the contents. I think she didn't pay enough attention to the impact of the quality of satellite data on primary production. By this I mean weather conditions, clouds, the ocean surface, and these factors might have an impact on the assessment of primary production. And the second remark is as follows. I think she gives an imprecise description on page 74. She uses the data of foreign sensors, therefore she should have used the terminology which is appropriate for such sensors, L2, L3 and so on, but she uses Russian terminology, so this is an inconsistency here, I think. But the work makes a very good impression, and I think the thesis complies with the requirements. And Polina Lobanova should be awarded the candidate of the science in geography. Thank you, Professor Kapilevich. Please answer the questions.
Thank you for your remarks. In my research, I used the color data of the ocean from CCI Ocean Color Initiative project. This is a European Satellite Agency version 2. This is an aggregate data from 3 spectroradiometers. For atmospheric correction, they use the polymer algorithm, which has been considered effective recently. It tackles the atmospheric signal perfectly. Before the analysis, all satellite-derived data on ocean color were filtered to exclude these so-called accidental emissions that we can find in the cloudy areas. Nonetheless, the validation of primary production models. The ocean color data can really affect the total inaccuracy in the primary production retrieval much more than other parameters. So satellite-derived data on ocean color is really crucial in the results of PP retrieval modeling. When satellite data is replaced with in situ data, then the correlation we see is more relevant. We use data of European and American agencies. According to their classification, the data I used may refer to level 3 data. This is data which is averaged by certain spatial and temporal parameters. As I said, I used 8-year data. In section 4, to define inaccuracies in primary production retrieval, I used the 4-level data. According to NASA, this data uses the 3rd-level data. Professor Kapilevich, are there any questions or some other remarks that you have? I find the explanations quite relevant. Still, I find one factor very important. I hope that Lobanova will continue her studies and will focus on that issue again. Another parameter she has to focus in the percentage of average for different seasons and different satellites, the amount of data per cell of the grid. the candidate has obtained huge amount of data which requires further research. Still, I have a very positive opinion of Polina Lobanova's work. You can take a seat. We have one more report.
So I'm going to read out the report. Professor Zakharchuk, the report on the thesis is positive. However, there are some critical remarks. There is a drawback in the first section. The candidate for the degree does not have a subsection which describes the dependence of photosynthesis on other factors, such as the content of carbon dioxide in water, temperature, and different nutrients. The methods and the research findings, as well as their interpretation, are presented in the third and in the fourth sections. However, there's also another drawback here. The candidate for the degree thinks that the most accurate retrieval model is the one whose statistical errors are minimal in comparison with other models. However, each statistical characteristic has its own confidence intervals, and within these confidence intervals, the values cannot be regarded as equal, which makes it difficult to choose one most accurate model. So the models should be assessed taking into account these confidence intervals. In the thesis, the candidate for the degree shows how the accuracy changes in the season. For example, in autumn, the models work worse than in summer. But the candidate for the degree did not describe this inconsistency and variability. So why are the models less accurate in autumn? I would like to say that the research findings presented in the fourth section are very important. Here the author shows the sources for the errors that the models might have. She describes bio-optical parameters, the absence of vertical variability within the euphotic zone, in stratified waters, and the errors in assessing the photosynthetic parameters, assimilation number. However, these research findings have been obtained by comparing modeled assessments with modeled assessments. In one case, they were obtained with the help of the input parameters derived from satellite, and in the other case with the help of in situ parameters. The author writes that the model which is described as a field one is validated, but we do not find any information about its validation. Can we compare the assessments with in situ assessments? Because in this case, the research findings would not be as accurate. My overall critical remark is a limited set of objectives. Variability of primary production can be described with the help of the transfer equation and diffusion equation. The models that are described in the thesis take into account the influence of hydro-optical conditions on the rate of photoplankton production, but they do not take into account dynamic processes connected with horizontal and vertical advection and turbulent diffusion. I have some critical remarks about the text of the thesis. I do not quite understand which level of data was used for calculating primary production. I believe this is the data of the third level. However, in the text we read the following. In the thesis we used several types of satellite-derived information of the second and of the third levels. What do you mean by that? You did not describe all the statistical methods used for the validation of the primary production models. For example, you give the ANOVA coefficient, but you do not describe the interpretations. So these are my critical remarks. Please, Polina, give your reply to my questions.
I should have included another section into the first chapter of the dissertation that could focus on the primary production models and their dependence on the factors, environmental factors other than light, concentration of nutrients, temperature, CO2. Zwalinsky in 2006 made a thorough classifications of such models. However, these are only empirical models and they are not accurate enough. For this reason, I didn't pay attention to that and decided to focus on the history of the modeling of the photosynthetic curve, which depends only on one factor, which is underwater light, as the major energy factor in this process. When assessing the quality of models, it was important for me to define one particular model. However, I do understand that when we work with statistical models, we have to consider the interval of the confidence intervals of the statistical models. Using this method, we can focus on several models, of course, but our aim was to choose only one that would consider spatial and temporal parameters because I studied regions. However, in my future research, I would like to focus on other models which consider the confidence intervals. A question about low accuracy of models in seasons. Well, actually, it was beyond the scope of my study, and now I can only make some theoretical assumptions of the reasons. Let me repeat myself. When I analyzed inaccuracies in the primary production models, I saw several major reasons. The accuracy in bioptical parameters, environmental conditions, and the accuracy in the assessment of photosynthetic parameters. I can suppose that in autumn, due to maybe cloudy weathers, satellite-derived models have lower correlation than in summer season, which in its turn affect the accuracy. Talking about photosynthetic parameters, the change in the species may lead to a different value in the speed of photosynthesis, and parameters of photosynthetic curves can change. In my study, I used summer, spring, and autumn parameters, and I focused on average parameters. They were constants. However, in autumn, these parameters were a bit different from the real ones. We focused on a pixel of 4 by 4 kilometers. In autumn, when winds change and when picnic lines is feeble, then some local blooming could take place. and on the level of 1 pixel, this was not considered. So the correlation between satellite-derived data and in situ data was a bit different. In summer, it's not that windy, so it doesn't affect the picnic line. Talking about the Japan Sea and the model that we use there as an analog to the in situ model of primary production. There is a deficit of data, as I said, so we had to refer to the models of primary production. This model was developed in the Pacific Institute. It's an analytical model. It's based on the theoretical assumptions on the cyclicity of the process. The developers of the model developed that for 20 years. They didn't compare the in situ data with anything because there is no in situ data. They focused on the phytoplankton typical for the Japan Sea. They experimented on how photosynthesis changes depending on the light. And theoretical and experimental curves really had a lot of coincidences. They were almost equal. So this model seems trustworthy, and we used it as an example to follow. Talking about the dynamic conditions, in my study I analyzed statistical connection of the measured primary production with the model parameters at a particular point in time, at a particular point in space. I didn't focus on the mechanism which leads to spatial and temporal change of primary production and growth of phytoplankton, which is controlled by dynamic process connected with horizontal and vertical advection and turbulent diffusion. Some minor remarks. In my research, I calculated about 14 statistical parameters. They're all given in the appendix. When describing the results, I couldn't describe all of them. There are too many. I only used the most representative ones. Still, all the 14 parameters were considered when choosing the most effective model. Talking about the ANOVA coefficients FEP, to calculate them, I used the MATLAB software, and I suppose that the bigger the P coefficient, the closer are mathematical expectations of the compared rows. Still, I agree with you that I should have elaborated on that in the section focusing on methods of research. Thank you. I find your answers really satisfying. You can take a seat. Now the floor might be given to the non-board members. They're welcome with their comments and questions. Are there any people who are willing to take the floor now? No? Then the floor is given to the academic supervisor of the candidate, Associate Professor of the Department of Econology, St. Petersburg State University, Professor Bashmachnikov. Colleagues, ladies and gentlemen, Polina Lobanova is the graduate of the Department of Econology of St. Petersburg State University. After that, she enrolled in the postgraduate program at St. Petersburg State University. Now she teaches at the Department of Ecology, St. Petersburg State University. After her postgraduate course, she got interested in the possibilities offered by satellite-derived models of primary production retrieval. In fact, her dissertation, to a large extent, focuses on the research that was done after the postgraduate course. In fact, she has completed 2 dissertations. What can I say about her as a personality? She is a responsible employee. She is an independent thinker and a self-starter. I would also like to say that she is a hard-working professional. Have a look at the list of bibliography. All the 300 items we see there were read through thoroughly and rethought in a creative way. Polina Lobanova is the author of over 7 scholarly works. She has made numerous presentations. She got a second-degree diploma at an established conference for one of the presentations. She is also a grant leader from the Russian Foundation of Fundamental Research, and as part of this grant, she is going to continue working on this topic, and many of the critical remarks we heard today will definitely be considered in her future work. Thank you for your attention. Thank you. Now, colleagues, I would like all the members of the dissertation board provide their final remarks on the results of the defense. No more than 3 minutes per each candidate. Professor Vilonenko. I really enjoyed the way Polina Lobanova answered the questions. It was effective. I really liked her dissertation, though I'm not a great expert in this field. It's a comprehensive study. It is clear that she took really a lot of time and effort to complete it. Among the other advantages of the candidate, we have forgotten about one thing. She has 2 patents, and these 2 patents are connected with this study. I find it really relevant. There are no reasons why we cannot confer the academic degree of the candidate of science in geography, because her dissertation complies with all the requirements set in the relevant order. Thank you, Professor Vilonenko. I wouldn't like to repeat what Professor Vilonenko said. I fully agree with her. However, defense is a dispute. So I would like to add something to what has been said, something that should be considered in future. Firstly, the inhibition effect should be considered when considering the taxonomic configuration of the species. In autumn, some other species can dominate, those which did not dominate in summer. Secondly, models should consider geographical zones and areas. For certain areas, we might recommend a specific model. A model which considers local environmental factors, taxonomy, the relevant parameters, and so on. Ocean color is no longer a problem. You can consider it that in the models that you have used, you can just change one of the constants, for example, values of the suspended matter and constants of underwater illumination. I find it interesting to consider the zones we have low bioproductivity. It will be interesting to understand why bioproductivity is low in certain areas. It's also interesting to consider the areas with ultimate productivity. Maybe they should be given the title of especially protected areas, talking about dynamic process and turbulence diffusion. I'm talking about the turbulence diffusion of non-conservative components. This is about speed and chemical and biological transformations. This is where we find traditional correlations. I talked about the speed of changes in the phytoplankton, the death rates and so on. We cannot do without physical dynamic processes, the natural processes. We should not only focus on chemical and physical transformations. Nonlinear factors cause systematic effects. You have to deal with multi-factor data. Please do not use the term of photosynthesis, use the term biosynthesis plus nutrition. Here you need biogenic elements. Good luck with your future research. Thank you for your remarks. Now the floor is given to Professor Ishizaka. You're welcome.
Okay, I'm very enjoying to read her dissertation and also listening the presentation and the answer to the comments today. And I think it is very good work, and I do hope that you will expand your research and also maybe deepen your research further. And I'm very happy to work with you maybe in near future for this field. Okay, thank you very much.
Thank you, Professor Kopilevich. Thank you. It's the first time I've taken part in such a novel defense. I tried to take an outsider's view on the whole process. I really enjoyed how the defense was held. There were many questions, many critical remarks, and I really appreciate how Polina Lobanova answered all the questions. Her report was deep and comprehensive, so the overall impression is very positive. I think her thesis complies with all the major requirements on the procedure of granting academic degrees at St. Petersburg State University, and she can be awarded the academic degree of the candidate of science in geography. I'm really positive about Polina Lobanova's achievement. Thank you. Let me take the floor now. I also believe that Polina Lobanova's work is relevant. It's a novel study. It can find practical application. I really enjoyed her presentation. She's a confident speaker, and I find her answers satisfying. She is active in her publishing, with her publishing works. She often participates in national and international conferences. I'm sure that Polina Lobanova can be awarded the academic degree of the candidate of science in geography. Colleagues, members of the Dissertation Board, we have all provided our opinions on Polina Lobanova's thesis. Now it's time for voting. Let me remind you that the decision is valid when more than 50%, but no less than 2/3 of the board members have voted for it, according to the relevant legislation. So, who is for conferring the academic degree to Polina Lobanova? I have already provided my point of view. I'm voting for. I'm voting for. Of course, I'm voting for. Professor Ishizaka?
Yes, I was for.
I'm also voting for. So, colleagues and attendees, 5 of the 5 board members have voted for conferring the academic degree. So, Polina Lobanova has been awarded the academic degree of the candidate of science, specialization 250028 oceanology. Before we finish this session, I'd like to thank all the board members for their work. I would like to thank Dissertation board members who have joined us remotely, Professor Kopilevich and Professor Ishizaka. Thank you very much. Good luck in your research and studies. I would like to thank the organizers of the dissertation of defenses who managed to organize the dissertation despite certain technical difficulties. Thank you to one and all. We're closing the session.